trying to put those into my calculator. It won't take it. It's too much.
Oh, okay.
The
So hold on one second.
calculator that we pull up during the exam, will that allow us to put in?
So the exam will let you use the Desmos calculator. And
So
I
it-
will bring that up and show you how to do that.
Okay.
Oh, this does not want, hold on, let me try it this way. So many things plugged in, I'm trying to get my, and there we go, okay. Okay, so let me make that smaller again, and then we'll bring up Desmos over here. Yep. So this is what the Desmos calculator will look like when you see it on the exam. So I'm going to separate that out over here. So you can see Desmos and the review questions now. Yes. Are you able to see both?
There you, oh, now, yes, now they're side by side. Well,
No. Okay. I was trying to make this bigger, but okay, there we go. Okay. So number 2. So like if I were to type that into Desmos, and when I'm using Desmos, I can either like click on these buttons here, or I can use my numeric keyboard, which I usually prefer that, but it doesn't really matter. And if I want to do the parentheses, though, I definitely need to use these, right? So parentheses, the negative sign, oh, yes. So in Desmos, it's the same, so it doesn't matter. So -3, and then parentheses 8. And you can see it's doing the calculation over here as I go. Plus parentheses -2 minus 5 parentheses 6. Whoops, I forgot the parentheses. Parentheses 6 minus 3. So that's pretty much exactly, I just typed it exactly as it was. Now, if you're using a calculator and you understand the order of operations, you can skip some of those things, and then some of them you have to have. The other thing on a calculator is that like this sign here in front of the 2, on a calculator like my calculator here, it's not really, the minus sign is down by the period, and that, or the negative sign, and that's different than the subtraction symbol. So some calculators, they're different symbols, and if you type in the minus when you mean the negative sign, it'll give you an error. But on Desmos, they're exactly the same. Does that answer the question about this one, number 2?
yes, which also,
Yes?
and that would also take care of 8. So, yeah.
Okay.
Okay.
Yeah, so if you type it into Desmos pretty much exactly as it is, and then of course the order of operations would be that it would first do this because that's in the parentheses. And then it would do this multiplication here and the multiplication here, and then it would add all the numbers. And you can never go wrong with adding, parentheses like this into the calculator, right? Because it's basically going to ignore like these don't do anything. Whoops. I put an extra plus sign over here. That's what it didn't like. But see, when I got rid of those parentheses, they don't mean anything. So same with these parentheses here. See how it doesn't change the answer? But sometimes, particularly a problem like, it's going to look different if I do it in Desmos. So let me write it out. Come on. Doesn't, oh, there we go. Nope. Oh, it's not gonna, Come on. Sorry about that. I'm having a little bit of a technical difficulty because my pen doesn't want to work on that screen. Hate when it does this. Okay. If I have something like 3 minus 5 parentheses divided by 2 minus 7, if I don't keep those parentheses, then it would do the division first. So I would get a very different answer. So that's where it's really, and if you're typing this into Desmos, then what Desmos does is it creates that little fraction for you. So if I do, whoops. If I do, see what I'm doing here. So many things hooked up here. 3 minus, nope, come on. Let's delete all of that. Okay, so 3 minus 5. And then if I hit the division in here, see how it creates the little fraction bar for me? So now I don't need the parentheses in the numerator or in the denominator because Desmos is going to do the fraction bar acts like parentheses. So a numerator that's written this way with a fraction bar will take care of that for me. But if I were to do this, if I were to enter this onto a regular calculator and I didn't do the parentheses, it would do -5 divided by 2, and then it would do the rest. So that's something to pay attention to. Other questions that you all wanted to look at before we move into the other problems?
Sorry, Fernanda, but so for number 8,
Uh-huh.
it is different. It has like 2 equations with the equal sign in the middle. How do you put the equal sign in the Desmos?
Yeah, so for number 8, we're solving an equation. So that's going to be a little bit different. And you know what? I'm going to move this. I'm going to change my screen share because my computer is being a little bit of a pain. So let me reshare this. Okay. All right. And I think now it will let me do the annotation. I hope. Let's see. Oh, where'd you go? Oh, there we go. Okay. So for this one, I'm solving. So I have -3x plus 7 equals -8 times 2x minus 7 plus 2. Uh-oh, I'm going to run out of room there. Okay. So for this, I have to solve this equation. And so the first thing that I want to do when I'm solving an equation is what? Do we remember? So we want to start by simplifying the left side and simplifying the right side. The left side is as simple as it gets because these two terms don't have anything in common, so they're as simple as they get. So I'm going to leave the left side alone. But the right side, I can do some simplifying. So the first thing I want to do when I see these parentheses is I want to distribute. So I'm going to multiply -8 times 2x and -8 times -7. So far, so good? Now on the left side, I have some like terms. What can I combine on the left side?
Does combine on the left side, the 7 and the 56 plus 2.
Yes.
And then
So I can, I'm not on the left side, I'm sorry, on the right side. The left side, I can't combine anything yet. But these two I can combine, right? 56 and 2.
58.
Yeah. Okay. And now, so now I've got the left side is as simplified as it gets. The right side is as simplified as it gets. So now I want to get all the variables on one side and all the constants on the other side. Doesn't matter which side, but let's say that I decide I want variables on the left. So that means I'm going to get rid of this variable here. How do I get rid of minus 16x? What's the opposite?
You add it.
Yeah, so I add 16x over here and 16x over here. And then these two combine to give me 13x. And I leave that 7 alone. These 16x's cancel. And now I want to get rid of the 7 here. So the opposite of add 7 is subtract 7. And so I end up with, we'll write it over here, 13x, the 7's cancel, and then I have 51. And then I have one more thing I have to do. What's that?
When you want the x by itself.
Yes. And here I have 13 times x, so I'm going to divide by 13. So the 13's cancel, and I just have x over here. And then 51 divided by 13 is, doesn't go in evenly, does it?
No. That's why I wasn't sure if in the exam, if we needed to know
You can leave it like this.
so we'll fill it in.
That's a perfectly good example, 51 over 13. It doesn't simplify. You could write it as a mixed number, but there, if it doesn't ask you to, then this is just as good as a mixed number.
Okay.
Mhm.
I was just trying to see if that's something that we could put into the Desmos, or do we need to work it out?
Well, so I could, let's see. Let me bring Desmos back up again. So we had 51 over 13. Okay. So notice that over here, Desmos tells me what it is as a decimal. So I could write the decimal and round if it asks me to round to a certain number of places. The other thing that I can do is I can write it as a mixed number. So it's going to be 3 and some change, right? So to figure out what that mixed number is, I could do something like 51 over 13 minus 3. And then I can convert that to a fraction. So I just hit this little, so this gives me the decimal. So I know that 51 over 13 is 3 plus 0.92. And if I want to know what fraction this 0.92 thing works out to be, I can just subtract the whole number part 3 and then hit here. So that tells me 51 over 13 is the same as 3 and 12/13. What other questions do we have about that problem number 8? Okay, so any other ones in here that you specifically wanted to see? What about you, Fernanda? Okay, so I mean, I had planned to work through these problems. Does that sound good? Yeah, okay. All right, so then let's see, we have the first one. So we've got the children are 7, 9, 1, 12, 15, 7, 8, 10, 7, and 5. So all of these we can do in Desmos. So I'm just going to copy, whoops, these guys, these ages. And then I'm going to go over to my Desmos. And I'm going to add a new, whoops, add a new line here. And I'm just going to paste those in. And then I can do something like mean, oops, parentheses, and then it will do that for me. The other thing that I can do is I can just create an ordered list in Desmos. And so I just give it a name, like I might call this variable L for list. So I can do L equals, and then I do the bracket. And then I type in, so now it has that list. And now I can calculate the mean and the median and the standard deviation and all of that. Now, Desmos doesn't, I don't think it does all of those for me. I don't think it does the mode, but I can do the mean. Whoops. And then I just type L. So you notice I get the same thing. I can do the median. Oh, it doesn't. Yeah, sorry, this calculator doesn't do the median. That's okay. I'll show you how to do it. I think it does standard deviation though. Yeah. Okay, so there's the mean and the standard deviation. I don't think it does any of the other ones, so we'll do those by hand, but let's just check. Yeah, so this is what this calculator will do for us. These are the functions. So for the other ones that we want, those are the hard ones though, not the hard ones, but those are the most computationally intensive. So that's the mean and the standard deviation. Questions about getting those? Okay. And then for the other ones, whoops, I hit the wrong button, sorry. So for the median, remember, we have to have these numbers in order to get the median. So what I'm going to do is I'm going to rewrite these, and when I rewrite them order smallest to largest, I kind of cross things off as I go to make sure that I'm getting them. Hold on, I want to get rid of that purple because it's distracting me. There we go. Okay. And so I'm going to find what I think is the smallest one, which is 1, and I'm going to write that one first. And then it looks like 5 is the next biggest. And then we've got 7 3 times, so I'm going to cross those off. But I'm going to write 3 of them. And then I've got 8, 9, 10, 12, and 15. Okay, and I just cross them off as I go to make sure I've got them all. And then for the mode, I just want which one shows up the most. And you can see that there's the 7 is 3 times, everything else is listed only once. I mean, 7 is the mode. It's the one that showed up the most. For the median is the middle, but when I have an even number, like here I have 10 children, so I have an even number. So that means I'm going to actually have 2 in the middle. And one way to kind of easily find the middle is to just kind of cross one off from each side and keep crossing one off from each side until you're left with either 1 or 2. I have an even number, so I'm going to be left with 2. So to find the median, I'm going to add those 2 up and divide by 2. I basically just average them. So the median is 7.5. Yeah. And then we have to find the range, we're just subtracting, right? The biggest one is 15. The smallest one is 1. So the range is 14. So just the biggest one minus the smallest one. What about the mid-range? So for the mid-range, we just take the range that we just calculated and divide it by 2. And that's all of them. So I would do the mean and the standard deviation in Desmos. And then the rest of them you're going to do like we just did by hand. Questions about those?
Sorry, the answer key says the mid-range is 8.
The mid-range is 8. Oh, yes, that's my bad. I told you wrong. What did I do wrong?
I don't
The mid-range, good catch, is we're actually going to add the smallest and the largest. So it's smallest, not, we don't subtract, we add smallest plus largest divided by 2. So the smallest was 1, the largest was 15. We divide by 2. 16 over 2 is 8. And there you have it. So for the range, we're subtracting. For the mid-range, we're adding. All right, thank you, Pamela. Good catch. All right, any other questions on that one? And we did 2. So let's take a look at 3, the least common multiple. And we have a couple different ways to find the least common multiples. When the numbers are large like this, I prefer to use prime factorizations. If the numbers are smaller, like, maybe I wanted the least common multiple of 14 and 20, then I might just list the multiples of 20. That's probably faster. But for this one, I'm going to write the prime factorizations, and I'm going to do that with the factor trees. So there we go. So for 198, and to do a factor tree, I usually just like look at, do I see a number that divides in? And I see that 2 is going to divide in because it's an even number. It ends with an even number here. So 2 goes in there 99 times, yeah? 2 times 99 is 198. And this is also an okay place to use your, for a bigger number like this, to pull out your calculator and just notice that it divides 2. You can either do the long division or you can do 198 divided by 2 and you'll get 99. And then now 2 doesn't divide in, but right away I see that 9 times 11 will give me 99. And 11 is prime, so now I just need to factor 9. And how do I factor 9? That would be 3 times 3. So now I've got all prime numbers, 2, 3, 3, 11. So up here I'm going to write 198 is 2 times 3 squared times 11. And then I'm ready to do a factor tree for 186. So I'm going to do the same thing again, and I notice again that 2 divides in there. And this time 186 divided by 2 would be 93. And then 2 doesn't go into 93, but I notice that 3 would divide in. So I'm going to do 3 times 31. What about 31? It's prime, isn't it? So that means for 186, I have 2 times 3 times 31. And now for the least common multiple, I want every factor that's in each of them. So they both have a 2. So I'm going to use the 2. I have a 3 squared and a 3. So if I do 3 squared, that takes care of this one. It also takes care of the 3 in here. So I don't need 3 of them. I only need whatever's the biggest amount that I have. So I've taken care of this, this, and this. And now I need an 11 for that one. And a 31 for this one. And now I just multiply all those together. I'm going to use Desmos because that's pretty big multiplication. So 2 times 3 times 3 times 11 times 31. Whoops, that's not what I wanted to do. There we go. I get 6,138. And I could check that if I divide 6,138 by 198, I should get a whole number. And I do, I got 31. And I could also divide by 186 to make sure that I did it properly. And then for the greatest common multiple, since I've already done this work here, the greatest common multiple, I'm kind of doing the same thing, but now instead of taking the largest amount of each factor, I'm taking the smallest. So they both have a 2, so that's in common. Now, this one has a 3 squared and this one has a 3, so what they have in common is just the 3. Right? This one only has a 3, so I'm taking the smaller. And then this one only has the 11, so I'm not going to include it. And this one only has the 31, so I'm not going to include that. So I just have, whoops, I put GCM. I meant to put GCF. Sorry about that. Just noticed that. Whoops. It's the GCF. Sorry for being confusing. Okay, so they share a 2 and they share a 3, so the greatest common factor is 6. And again, I can check that. I can divide 198 by 6 and 186 by 6, and I should get a whole number for both of those. And I find what sometimes people confuse is this one is the least common multiple, and this one is the greatest common factor. So sometimes people confuse them because this one's the bigger number of the two, right? But it is the least common multiple because of all the multiples of 198 and 186, this is the smallest one. What questions do we have about 3 and 4 then? Questions? Did I get those right, Pamela?
They match, yes.
She's checking for me. Okay, good. You got to watch me. I always say it's harder to do them on a chalkboard or on a whiteboard. Okay, but I, as a student, I was very mistake prone too, so I always had ways of checking my work to make sure it seemed reasonable and correct. What about 5 and 6? Those we're just going to use the formulas, right? So we have those two formulas. I don't memorize those, but those you'll have on your formula sheet, right? So you're going to have that formula sheet. So for Celsius to Fahrenheit, we have C is equal to F minus 32 times 5/9. Is that what you have on your sheet? And then for the other way, we have F equals C times, do you have 9/5 or do you have 1.8? You might have it like this. I can't remember which one we put on the sheet. Sometimes we write it like this, 1.8. Those are equivalent, 1.8 and 9/5. And we can actually use, with algebra, we can use either equation to solve both of these problems, but it's usually easier for one like number 5, since I'm converting Celsius to Fahrenheit, and I'm going to plug in Celsius and I get Fahrenheit out, then this equation is a little bit easier to use for number 5. And so since I'm converting 32, I'm just going to replace the C here with 32. So Erase that C. Put 32. And then that's another good one to do. Like I would just use calculator for that. I have Desmos open on my other screen, so I'm gonna maybe if I can get my I lost my lost my mouse. Okay, there we go.
So whatever number they give us, we put that in place of the C or the F.
That's right. Exactly. So 32 times 9/5 and then plus 32. Whoops. Oh. I get 89.6. Is that what you got when you used your calculator? Lost my pen. There it is. Do
Well,
you get
that's what
89 point? Yeah,
answer key says.
89.6. Okay. So 89.6. Oops, 6. And then, yeah, for this one, we're going from Fahrenheit. So 56 degrees Fahrenheit. So I'm going to do Celsius equals 56 minus 32 times 5/9. Let's see. So 56 minus 32. And this is another one. I'm just going to bring up Desmos to make sure that we see this one. Okay, so 56 minus 32, if I just do times 5/9 like this, then it's only going to multiply the 32 times 5/9. So this is one where I need those parentheses. Whoops. I need those parentheses. Oops. To go here, like that. And then I have to add in the, no, that's it. Okay. So if oh, I lost my other sheet. Hold on. There we go. Did I do that one right? Yeah, we are converting to, yes, okay. So very important to get the 5/9 outside the parentheses. If I don't have the parentheses, it's only going to multiply the 5/9 times the 32, and then I'm going to get the wrong answer. Yeah. So make sure we keep those parentheses. Questions about that guy?
So
Nope, I want to share this.
I put it into
Oh.
my calculator and I just get a fraction. I get the 40/3.
Oh, So, what calculator are you using?
If you can see, it's just a,
Do you have a key that looks like S arrow D? Like S and then a two-sided arrow and a D?
oh, I have an FD.
That might be it. What happens if you hit that?
13.3333.
Yes, that's the one. So some calculators will give you answers in improper fractions, but they usually have that key that will toggle back
Okay.
and forth to decimals for you. All right, so we're good on those conversions. Now, number 7, here's one is, did I share this properly? Are you able to see the study problems again? Yeah. Okay, so this one, number 7, is one that I think on the homework we had a similar one, and some people got confused on this one. So we want to make sure that when we talk about a difference between A and B, we mean A minus B. So it might be helpful to write this out. We want the difference in lifespan between someone who regularly works puzzles. So I'm just going to write puzzles for someone who regularly works puzzles and someone who frequently feels stressed. So stressed. So I want to find the lifespan difference for puzzles and subtract the lifespan difference for stressed. So where's puzzles? I'm guessing that's going to be plus something, right? Oh, here we go. Regularly work puzzles. Oh, I like to do puzzles. Good news for me. Okay, so plus 5. I'm going to keep this minus sign. And then someone who regularly feels stressed, what value do we have for right here? That's between the -6 and the -4, so that must be -5. So I want to make sure I get the order properly, and I have 5 minus -5. And then remember, subtract -5 is the same as add 5. So I can rewrite that as just 5 plus 5, which is 10. So the difference in lifespan between someone who regularly works puzzles and someone who frequently feels stressed is 10 years. What questions do we have on that one? All right, and then let's see, we did number 8. And then number 9, we have the complement and the supplement. And remember, the complement is the number of degrees in an angle that would give me a total of 90 when I combine with this. So for the complement, I'm just going to take 90 and subtract the 27 degrees. So that's going to give me 63. For the supplement, remember, supplementary angles add up to 180. So I'm going to do 180 minus 27. So supplements add up to 180. So we've got 180 minus 27. So that's going to be 153. All right. And I remember these because complement comes before supplement in alphabetical order. C comes before S. So the smaller one is the C and the bigger one is the S. So that's one way of remembering those. I like making associations. Questions about that one? Okay. Let's clear those out. And then converting. Well, there's a fun one. So converting 27 pounds, 5 ounces to kilograms. And then we want to round to the nearest 1/10 of a kilogram. And they gave us, now you get to have that sheet of conversion factors, but sometimes they'll also give it to you. But the first thing that I need to do here is I need to convert everything to pounds, right? Because if you look at my conversion factors, I have the conversion factor, which tells me how to convert pounds to kilograms. And then I have the conversion factor for ounces to pounds, but I'm given 27 pounds, 5 ounces. Okay. And so before I can convert this to kilograms, I need to convert my ounces to pounds. So another way of thinking about this is that this is 27 pounds plus 5 ounces. We don't usually write the plus, but it's kind of implied there because it's a total of 27 pounds and 5 ounces. And then to convert those ounces to pounds, I'm going to leave the pounds alone. And then to convert the ounces to pounds, I'm going to think of this. I can always write over 1. That doesn't change my values. And then I'm going to use this conversion factor. And I'm going to write it as a fraction, and I want to have in the numerator the equivalence that I want to convert to, which is pounds, so 1 pound. And in the denominator, the factor that I want to convert out of, which is the ounces, so 16 ounces. This looks confusing. Let's make that a 1 like that. Okay, 1 pound over 16 ounces. So now when I multiply these two together, my ounces cancel. So I have 27 pounds plus 5/16 of a pound. And then it might be easier before I convert further to make this an improper fraction. So to make it an improper fraction, remember I multiply the 27 times 16 and add it to the 5 that I already had, and then I keep that denominator of 16. So I have 27 times 16 plus 5, all over 16. So far, so good? And then I'm going to use calculator for that. 27 times 16 plus 5. So 437 over 16. So I'm only going to simplify the numerator. I'm going to leave the denominator alone for now. So I've got 437 over 16 pounds. And now to calculate or to convert that to kilograms, now I'm going to use this factor. 1 pound is 45 kilograms. I'm going to rewrite this guy over here, 437 over 16 pounds. And I'm going to multiply by my conversion factor. And this time I want the pounds to go away, so they're going to go in the denominator. So 1 pound. And then in the numerator, I have 0.45 kilograms. So now I can cancel out pounds, and I have 437 times 0.45 divided by 16. Or 37 times 0.45 divided by 16. And I get 12.290625, and it tells me to round to the nearest tenth of a kilogram, which means I'm going to keep 1 decimal point here. And since the digit to the right is 5 or greater, I'm going to round up to 12.3 kilograms. What questions do we have about that one? All right, let's see what else we're getting short on time, so let's see what other ones. So we've got a circle graph, we've got another graph here, a bar graph, we've got a frequency table, we've got some angles, triangles, parallel lines and angles, more conversion, scientific notation, rounding. Which of those things are you most interested in looking at? What would y'all like to see?
For 14,
For number 14?
yeah. Is
Okay.
that, um,
Okay, so let's see, we have 370 graduates.
yeah,
And if this is accurate, how many in a group of 100 are between 23 and 26? So what I want to do first is figure out how many are between 23 and 26 for this group, right? And if I look at my graph, 23 to 26 is going to be this box, right? And this line up here represents 80. I'm not quite to 80. And between this line here and this line here is 20. So this looks like maybe, I don't know, 77, 78. So I'm going to guess that it's about 77 out of the 370. Okay. And I have to estimate since I don't have, an exact. So 70 would be halfway between, like about right here. So that looks like about 77 or 78. Okay, so this is the fraction of my graduates who are between 23 and 26, 77 out of the 370. And so what I want to do is I am assuming that if that's accurate ratio of how many graduates fall into that age range, then I should be able to compare for any given size group. If I put the group size in the denominator and the number of 23 to 26-year-olds in the numerator. And if I set them equal, I should be able to fill in the missing part. So I have a group size of 100. So I want to know about how many 23 to 26-year-olds there would be. So I'm just setting up this proportion since I'm assuming that these ratios are going to be the same. Does that part look like something you've seen before? And then to solve this, what I do is I do that cross multiply. So anytime I have two ratios that are equal, like we know 1/2 and 2/4 are equal, and we can always multiply numerator times denominator, numerators times denominator, and they'll be equal. So we use that to solve something like this. So then I know that 77 times 100 has to be equal to x times 370. So then I can multiply 77 times 100 is 7,700. That has to be equal to 370 times x. And then to find x, I can just divide by 370. So 7,700 divided by 370. I get 20.81. So I would say about 21 graduates out of 100. I would just round that up. A question like this one, since it's the number of people, we would use whole numbers for that. What is the solution on that one? What do they have listed, Pamela?
About 21.
Okay. So, if you picked, if you maybe picked 74, 75, you would, but if you're within 1 or 2 points on either side, you'll get close enough. This is not one for which we would get an exact answer. All right, we have time for at least one more. Do you have a preference? Or what about you, Fernanda? Anything you want to see? You can type it in the chat if you don't want to speak into the microphone.
Well, I would assume that there would be some kind of half-life equation in the final. Is that
That could definitely be a possibility. Yeah.
just
Do
doesn't
we not have one in here, or is there one?
I don't know. I don't see one. I see weights like milligram,
Yeah.
kilogram, and things like that, but not a half-life.
Okay, let me find,
I know the last exam, I believe it was on the last exam, we had some questions that were half-life and then some times with, or maybe they were just part of the weekly homework, um,
mhm.
that were in between that. And when I tried to just half the half-life time, it was way off.
Oh, I know the one you mean. Let me see if I can find that one.
I don't
So,
know if that was something that was um, on the final. That's one of those things that is really stressful.
yeah. Let me think. Was that in here? Nope, that's, I think module 6, maybe? Exponents and, well, no, no, no. Algebra, geometry. Yeah, that must be it then. mm, was it in here? No.
I don't remember what page it was.
I thought it was module 6. Let me look in this applications questions and see if we can find it here. No, that's not it. Darn it. Um, no. That was 7. Let's see. Was it 8? Hmm. I know we had this. Oh, this. Okay, here we go. So let me find that application question because I think that's the one you're talking about. Okay. Okay, here we go. So this is is this the one you mean, the virus? Oh, no, this isn't Half-Life. Oh, here's a Half-Life. Okay. So the half-life is 9 hours. So if someone is given a 2 milligram dose at 10 a.m., what's the correct half-life formula? So what goes here is the dose. So the dose was 2 milligrams, so that's this part of the equation. And then we're talking half-life, so the fraction we want is half. Okay. And then the half-life is 9 hours, so we're going to do T over 9. So this would be the equation. Okay. So in other words, in 9 hours, the half-life has happened one time. In 18 hours, the half-life has happened 2 times. So that's why this is the correct formula here. And let me write that one down so that we can use it for the next question. Okay, so the amount in someone's bloodstream is equal to the initial dose times 1/2 to the T hours divided by the number of hours in the half-life. We'll write H for half-life. So for this problem, the amount is equal to the initial dose, which is 2 milligrams, times 1/2. And then since the half-life is 9 hours, we have T over 9. So this is the equation we're going to use to answer these questions. Okay.
So next to the 2, it was an equal sign, not a minus sign?
Yes.
Okay. It was little and I was trying to really look.
Oh, yeah, I'm sorry. These are equal signs. Yeah.
So I can see your writing, but I was trying to
Oh,
the screen, then it looks like minus.
oh, I see what you're saying. Yeah, these are all equal signs.
Okay.
Yep. This is a formula. So you tell me how many hours ago the person took that dose. I can tell you how much of the medication is still in there. So the input is T, the number of hours that have elapsed since they took their medicine. And then the outcome, the amount, is how much of the medicine is left. So for this question, how many milligrams are left at 7 p.m.? So we have to think, okay, if they took it at 10 a.m., from 10 a.m. to 7 p.m. is how many hours?
9 hours.
9 hours.
Yeah.
Yes. So plugging into here, the amount that's going to be left is 2 times 1/2 times 9 over 9. That's just 1, right? So in other words, we've only had one half-life, so half of it's left. So 2 times 1/2, or just 1. So 1 milligrams left after 9 hours. And then I think the next question was the one that is the more challenging one. Oh, no, this is 1 p.m. the following day. Okay.
Yeah. So that's
Okay, so if you take the dose at 10, then from 10 a.m. one day to 10 a.m. the next day is 24 hours. So 10 a.m. day 1 to 10 a.m. day 2 is 24 hours. And then from until 1 p.m. the following day would be plus another 3 hours, yeah? So this is 27 hours. So now we're going to do the amount is equal to 2 times 1/2 to the 27 over 9. So that's going to be 2 times 1/2 cubed. Or remember, cube just means multiply 1/2 times itself 3 times. And then these two are going to cancel and give us 1. 2 times 1/2, that's 1. So I have 1 times 1/2 times 1/2, or 1/4. So I've still got 1/4 of a milligram in the patient's system the next day at 1. All right, anything else we want to see? Are we feeling pretty good about next week?
Not really.
Not really?
I'm nervous about even doing the test today. I was going to take it last night and then I got up this morning and just started watching all your videos over and
Okay.
over. I'm nervous about it.
Yeah. Well, you've studied a lot, so go in confident, go in strong and
Yeah.
yeah.
Will you post this?
Yes. Yeah, so as soon as I stop this, I'll have to wait for it to finish processing and then, but yeah, I'll start working on that. So as soon as it's all processed and ready to go, I'll put it up. I can't remember, are you in my section?
No, I'm in Dr. Vakil.
Oh, it doesn't matter though, because you know how to get to the YouTube, right?
Yeah.
In
Yeah.
case she doesn't post it right away. Yeah. Okay.
She's really good about it.
Oh, okay, great. Yeah, so I always email the other instructors when it's ready. And but it's you can always get it in YouTube as well. So hopefully later this afternoon. Sometimes it processes fast and then other times it's a lot slower.
Yeah. Okay.
All right. Well, thank you both for coming.
Thank you. I appreciate it.
Yeah. Stay strong. You got this. All right. You all have a great day. Good luck with the final. If you, as you're studying, if you have any questions, you can also just email me as well.
Okay. Thank you. I appreciate it.
Uh-huh. Have a great day.